Hello students, and welcome to the lesson on bit string flicking. And this is a topic for the American Computer Science League, but in general this is dealing with Boolean algebra, just a little bit of Boolean algebra. Boolean algebra is actually much more complicated than this, but this is a very brief introduction to it. And so we'll start with this definition of a bitwise operation. It's an operation on individual bits, okay, or in other words, on an array of ones and zeros. Okay, so imagine you had an array that's filled with just ones and zeros, and we're going to perform some operations on that array. So let's just dive right into it. It's probably easier to talk about these concepts after looking at some examples. So we have some operators here. So first operator is AND, which is evaluates true if both bits are true. Okay, and true here, we define it as 1. Okay, so the common symbol for this is the singular ampersand. I know many of you are programmers, and you may have seen in Java or C++ or Python, you might see the double AND, but that means something actually a little bit different than the single AND. So maybe let's look at a quick example here of the AND operator. Okay, so here I have an example. I have two bit strings, 10101 and 01100. We perform the bitwise operation, and basically we look at each of these bits, and if both of them are ones, then the result is a 1. If it's any other scenario, then it's a 0. So this is a 1, this is a 0, so when you perform the AND operation, it's a 0. These are both zeros, so that's a 0. Both of these are 1, so that's a 1. That's a 0 here, so when we perform the AND, it becomes a 0, and same thing here. Okay, so when we perform the AND operation on these two particular bit strings, this is what we get. Okay. Next, we have the OR operator, and it evaluates to true if either bits is a 1. So if either of the bits is a 1, then the result will be 1. We typically use this symbol here, the singular pipe, and again in Java and C++ and Python you might be familiar with the double pipe. That means something different than in this case here. Oh, I also forgot to mention that oftentimes people would just write out the word AND, or they'll write out the word OR. This is very common as well. So here let's do the exact same example that we did before, except this time using the OR operator. So right to the side here so that we don't clutter this up too much. So here, if either of the bits is a 1, the result is a 1. So that's a 1. These are both 0, so that remains 0. Both of these are 1, so that's a 1. One of this is a 1, so that's a 1. And one of these is a 1, so that's also a 1. Okay, so AND means that both of the bits have to be a 1 in order to get a 1. OR means that either bit or both bits could be a 1 in order to get a 1. Okay. Next we have the NOT operator, and this flips the values of every bit. So whatever used to be a 0 becomes a 1, and vice versa. And typically the symbol that we use is this tilde. Again, in programming languages, you might be familiar with the exclamation point. That means something a little bit different than this here. Okay, the exclamation point in Java and C and Python, that does not mean a bitwise operation. This actually flips all of the bits. Okay. So let's do an example, and let's go with one of these bit strings that we had from before. Okay, so if I took that bit string and I applied the NOT operator to it, then all it does is whatever is a 0, so that first one was a 0, now becomes a 1. This is a 1, so that becomes a 0. That's a 1, becomes a 0. This is a 1, and finally that's a 1. Okay. Oh, and I also should mention that sometimes the operator that gets used for this is just the word not by itself, like that. Alrighty. So next we have what's called the exclusive OR operator, and this is evaluates to true if exactly one bit is true. Okay. So this is a little bit different than the normal OR. The normal OR is either bit, or both of them could be true. This is that exactly one bit. You can't have two bits. Okay. So another way to think of this is exclusive OR evaluates to true if the bit values are different. And the symbol that many people use is the XOR, just writing out the word XOR. Sometimes they will use this plus sign with a circle around it. That means the same thing as exclusive OR. And let's take a look at an example. Maybe we should do the exact thing we did up here, okay, so you can kind of see the difference. Okay, so we look at the bitwise, each of these bits, and again, we only evaluate to true if one and only one bit is true. So here you have a 1 and a 0, so that becomes a 1. Neither bit is true, so that stays 0. Here, this is where there's a difference. Both of these bits are true, so that actually evaluates to 0. So this is like saying one or the other, but not both. So here, exactly one bit is a 1, so that stays true, and then here, same situation. Okay. So if you have two zeros or two 1, that will evaluate to false. If the bits are different, 1 0 or 0 1, that will actually evaluate to true. Okay. So there you have it, just a very brief introduction here to bitwise operation. I'm going to end this video here and start another one on the more complicated operators: left shift, left circulate, and right circulate. Be sure to watch those videos. Thank you for watching. Have a wonderful day.